Okay, here's a lab scope picture of a fuel injector. Now, what I'm looking at is the digital representation of that injector being turned on and off. That's an electrical signal from the injector to the injector being turned on and off by the PCM. Here's my system voltage. You see it's about 14 volts. Here's when it turns it on, near zero. This, from here to here, is called my pulse width. That's my injector on time. That's the amount of time that my injectors are held on. Here, this little spike right here, I can see off this injector, that's when it's turned off. And it comes back down to system voltage. Okay, so on here, I can see, while I'm looking at this picture, I can see my pulse width. I can see my injector being turned on. I can see what it's being turned off. I can see the spike, which is important if it's shorted out. For example, if this everyone's doing 68 volts, 69 volts, and I got one doing 59, it's a short injector. And also on deceleration, I can tell me my injector closes. Got this pulse width, it gets much smaller. Here, I can see the injector, I don't know, it's closing acceleration right now, like an accelerator on this one. See this pulse width got much wider. They got closing here. It's actually opening. But when they revved it, it opened up. The pulse width got much wider. But when they let the throttle go, close it, it's going to get much smaller. So here I'm seeing my system voltage. It's like they revved the throttle here. My pulse width, my injector pulse width got much wider, almost 4 milliseconds here. But now, once that throttle is released, this pulse width, this closing right here, is going to come all the way over here, indicating the injector is closing. Here's my spike again. Opening, acceleration, turn off, my spike. And once it closes, the next frame should have been this closing point here, moving all the way over here, indicating the PCM is turning off the injector, closing the injector. Alright, let's go to the next one.